Hey guys, welcome back to the channel. Today we'll be solving 2-sum 2. So the difference between this 2-sum and the last one is that the input array is sorted. So we're giving a one-indexed array of integers called numbers. So the only weird thing about this problem is the indexes don't start at 0. So when we're returning the indice of the two numbers that add up to the target, we're going to add 1 to it because it's one indexed. So what would be the brute force for this? So the brute force would be a nested for loop with a time complexity of n squared, where we check every number and then every other number that could add up to the target. We obviously don't want to use this solution. So what we're going to use is a two-pointer technique. So let's get into the solution. We're given an integer array with 2, 7, 11, and 15, and we're looking for the target 9. So we're going to initialize two pointers, one at the start of the array and one at the end of the array. And at every iteration, we're going to calculate the sum of the values at these 2 pointers. So to begin, we're going to get a sum of 2 plus 15, which is 17. Now this sum is bigger than our target, which is 9. So we know, because that it's larger, that we have to move the pointer on the right side to the left, because a sorted array has the property that the numbers to the left are less than the numbers to the right. So moving the pointer from the right to the left will shrink our sum. So the next iteration, we're going to calculate the sum again, and we're going to get 13. This is still greater than the number we're looking for, which is 9. So we're going to move our pointer again to the left, which is going to shrink our sum once again. Now our sum is going to be 2 plus 7, which is equal to 9. We found our target, which is 9. So we're simply going to return the indices of these two pointers plus 1. So this is 0 plus 1 would be 1. This is 1 plus 1 would be 2. And that's our answer. We're going to initialize a pointer to the left at the start of the array and a right pointer to the end of the array. And then we're going to loop, we're going to do a while loop, and as long as the left and right pointer do not meet, we're going to keep going. So our current sum is the number at the left plus the number at the right. If this sum is equal to the target we're looking for, we can simply return the left and the right pointers plus 1, because this is 1 indexing, not 0 indexing. Else if the current sum is less than the target we're looking for, we can bring the left pointer to the right by 1 increment. Else, if the current is greater than the target, then we can move the right pointer to the left to decrease our sum. And since we're guaranteed a solution, we don't need to return anything at the end. Looks like it worked. Thanks for watching.